Okay, so let's start the training. Uh, so first, in the list here, you can see in the first page, I marking the. So this is the folder including all the program you will need to run step by step to finally we start to do the data taking. So in this figure, this is the like the setup schematic diagram. So once you are doing an experiment, you can try to you can look at this figure and you will understand what you are trying to do right now. And also this part is all the instruments you will use. So if you don't know which device you are working with, you can check with this figure here. So okay. So first, the folder is in these directions. So if you cannot find it, you can follow this direction to find this folder here. Okay, this including all the programs, review programs you will need when you do the data taking. And in this figure, it means so basically this including two switch back and forwards to do the experience. So the VNA help us to do the signal S22 parameter data taking, and signal analyzer help us to do the real data action data taking. And this S22 give you one important parameter, is the resonance frequency of the cavity. So once you get the resonance frequency of the cavity, and you need to set in the central frequency of the signal analyzer and start to doing an analysis. So please keep this experiment process in mind. You need to do the S22 and confirm the resonance frequency is correct. And then you change the central frequency of the signal analyzer, then run the experience. So, but the detail I will discuss later. And this is all the instruments you will use in the experience. So motor controller, so we need to tune the rod inside the cavities. PXIe chassis, this part. So this including a switch, a room temperature switch, and also the signal analyzers, as I draw in here. And also last is the VNA, like this. Okay, it will help us to do the S22 measurement, and also in the program I do the fitting. So the parameter is they're including all the parameters you need to use in the signal data in the data taking. And I also zoom in or show a figure for this room temperature switch. So you can see here there's a common port and NC and NO. Okay, so this is what I mean in here, NC and NO. So let's take a look on this. Once this switch, sorry, so why I drawing two switch here is because this have two switch here. So both of them are named after NCNO, NCNO, but just different like numbers 0 and 1 here. So okay, let's take a look. Once the switch is switched to O mode, so this is mean open. Okay, you are ready to doing the S22 measurement. Okay, and then if you switch this relay to closed mode, so this will no longer give a probe power to cavity, and in this part you are ready to do the data taking. Okay, then so let's start to go through the list. So there exists 5 experimental steps, and okay, don't worry, right now the experience is very easy, so just take a deep breath. Make sure you are not sober, you are sober, okay, and just take it as a walk. So first thing, look at the checklist and make sure what's the step number you are going to operate. So what I mean is, this is our checklist, and you can see it's much shorter than last time. So make sure what's the step number you are going to do. Okay, and these 2 rows here, it's just for you to figure out. This number didn't mean anything, but just for you guys as a reference when you do the experience. Okay, but the most important thing is this step number here. Okay, then so pay attention on the resonant frequency FR of the previous operation. So what I mean previous operation is the previous step that your previous shift takers trying to run. Okay, and keep these numbers in mind. And later on, you will get your own resonant frequency with the work with this VNA. And this resonant frequency is for your current step you are going to operate. So also keep this number. Once you get this number, just keep this number in mind too. And so reminds everyone, just remember to write in the logbook. Anything you do, anything you find something suspicious, just record it. Okay, we need more logbook records. Okay, so let's go through the steps of the experience. So first, make sure the relay, as I mentioned in previous slide, you switch the real line to VNA. So this is what I mentioned, that this 2-port is switched to NO mode. Okay, the open mode. And in this case, you are ready to do in the S22 measurement. So you just open this and click the run, and the relay will switch to open. And then you asking the motor controller to drive the rotator, and then you move the rod of the cavity. So in this part, we would like to change in the resonant frequency of the cavity. But you can see this still have some unsure number here. So this depends on Hsin's fitting. So I will fill this number up once the Hsin get the analysis results. So right now this is in this pattern you will see number of step is mean the step of the motor. So corresponding to this number, and corresponding, for example, if the half of the bandwidth is 80 kilohertz, and corresponding to this number, we will have some how many number of steps we will need to run, and I will change this number and make it default. And this forward backward means the rotator, for example, from 60 degree going to like 61, or 60 going to 59, etc. This means forward and backward. And if you remember from the mode mapping we see in the past, that as we know, the position increase means a resonant frequency increase. So right now you are ready to do an S22 measurement. You tune the motor. So right now you need to ask VNA to do the S22 measurement, and this gives you the phase information. And in here you see this red and white curve is this program also do the S22 fitting. So the red is data and the white curve is the fitting. And here shows the fitting result. Of course, we didn't have port 1, but I writing K01 here. So this basically means the intrinsic loss, and the coupling loss of the port 2, the resonant frequency, another important parameter, beta value. Okay, this means K2 over K0. Based on OM's report that this value should stay near 2. First, change your step number. So what I mean is this. Please remember to change this number. This number is basically means the folder on NAS. If you didn't change it, they will go into a wrong folder. So remember changing this number, and also run the program by push these buttons. Then check the estimate list. What I mean is this part. So make sure the beta is in some range, but I still don't know what's the range is. Also compare the resonant frequency with the previous resonant frequency. So you go back to this checklist. So the previous people should record the resonant frequency here. So once you get the parameter here, in this, if the frequency is 60 to 80 kilohertz larger than the previous record, then you record the K01, K2 resonant frequency on a checklist and give yourself a like. This is important. So basically this K2, K01 beta resonant frequency. So let me repeat again. Changing the step number, run the program, make sure the resonant frequency is okay, make sure the beta value is okay, then record K01, K2, beta, and resonant frequency. Sometimes the motor didn't work well, so maybe your resonant frequency will not in this range. Go back to step 2. So supposedly, like we're changing 80 kilohertz, this should be 10 steps. But if your number, like it goes to 52 kilohertz, frequency larger than the previous resonant frequency, then what you need to do is to change this number to 1. And because we need the resonant frequency increase, so make it forward, then run the program. So like manually fine tune the rod. And if this problem is solved, then everything is okay. Because we tune in the rod, the system temperature might increase. So in this status, you need to wait for system temperature drop to T6 lower than 30 millikelvin. And you should also record it in here. And then switch the real line to signal analyzer. So in this status, we are ready to doing a real data taking run. You just right now you open this program, axion measurement, and run it. This program is just asking the signal analyzer do the axion experiment data taking. So still one important thing, remember to changing the step number here. And also based on the previous VNA study, this is the frequency, central frequency of a signal analyzer. So you change this number to the resonant frequency you record from the VNA study. So this is the resonant frequency in your current run. Let's go through this list. Change the step number to the number you are going to operate. Change an FC this number. And this number is corresponding to the data you get from VNA. And one more important thing, please notice that this is some program like tricky part. From the VNA, the unit is gigahertz. From here, the unit is hertz. So make sure you type this G here. And then you confirm the step number is correct, central frequency is okay. Push this button to start the frequency, the axion data taking. The digit I set in, we have the frequency resolution 1 kilohertz. Type this number down to 6 behind this point here. Once you finish the VNA data taking, make sure the number is correct. Copy this number and type G here and run it. And this is all you need to do. And this basically is the real data taking length. So as we mentioned, 5 hours. So this should be 300 minutes. Okay. Second thing is they're including the total scan number. This scan number means how many 1 second scan we will need to do in the experience. Okay. And also this will show the current scan number. This will start from 1 and then directly increase. When it equals to this number, the program will stop by itself. 1 scan number will take some times. And I also times these times with the difference with these two numbers. So you can notice this number and know when, roughly guessing when the program will stop. I record the power trace in this figure. If the power is become larger or lower than this boundary, it will show alert here. It detects the power every minute. If you keep seeing this number lines up, maybe the gain or adding nodes have some problem. So in this case, I think just make a call. Don't directly stop the program, but just make a call and let the people take care about this part. Once you run into this program, it should be the end of the journal. And if you met some problems, like it lines up or the program is suddenly stop, just make a call and let the guys help you to fix it. Okay, so that's it.